I don't really have problem with anything, sir.
Everything is okay?
Yes, sir.
Sure?
Yes, sir.
Positive?
No, sir.
So tell me something you might need help with.
Sir, we don't do fractions yet, sir.
Sir,
Mr. John?
sir, I was not at class Wednesday.
I know. Go ahead, Zaria. I'm hearing you.
Sir, we don't do fraction as yet, sir. So I didn't understand fraction at school in grade 5, but I understand it now because we don't really do fraction. That's
I didn't get that. Repeat.
Oh, I said fractions. And we're not doing fraction at school as yet.
Mm-hmm.
So that was the only thing I have problem with in grade 5.
Okay. Well, we're going to go over some fractions today. All right?
Yes, sir.
All right. So let's go. All right, everyone. So let's begin. All right. So here we go. Fractions.
Sure.
All right, guys. Ready?
Sir, you're wrong, sir. Sir, but you're right. A fraction has 3 or 2 numbers, and it can has also have a mixed number, sir.
Right. It can have 3 numbers. All right, everyone, let's get that written down so we can begin. Bijan, why are you in with 2 devices?
Sir, one. Oh, sir, it wasn't me, no, my mama.
Okay. All right, let's go. Ready? Okay, Zaria, want to read for me?
Sure, sir. A fraction has two main numbers: the numerator, which is the top number, and the denominator, which is the bottom number. The numerator tells the amount of equal parts, and the denominator tells the amount of total equal parts of the whole.
Okay, great. Now, I want you both to tell me what you think that means.
So that the numerator, like, it tells us, like, say for example, 2 at the top, that tell us that how much is in the set, like how much is there, sir.
Okay, all right. And what do we know about those things? Are the things that are there equal or not equal?
Not equal.
Not equal? How come? What did we say about the numerator?
Equal.
Equal. The things in the numerator are always equal, right?
Yes, sir.
Okay.
But the denominator is not.
And the denominator, the things in the denominator, are they also equal?
Oh, sir.
Yes, they're equal. But what they tell is the amount of total equal parts. All right, Zaria, read here for me, please, again.
The top part,
The bottom one, this one here, fractions mean.
Fraction.
that part, sir, or the bottom?
Yeah, this part, the bottom part here.
Alright, fraction is equal parts out of the total equal parts of an whole.
All right, let's look at that for a minute. So here goes.
Everybody is dead.
A rectangle. What would you call this? How would you quantify this? How many rectangles is this?
1.
1. What say you, Zaria?
Once, no? Yes, sir. Yeah, once.
1. All right, so is this a fraction?
No, sir.
No, it's not. Why is it not a fraction?
Because there, oh, sorry.
Sir, because it's just 1 alone.
It's just 1 alone. So for it to be a fraction, what must we have? If it is just 1 alone, which makes it a fraction, what will make this a fraction?
Yeah, because it's not all.
If it cuts in that part. Excellent. So what we do here is that this is 1. But here is the same 1. But I'm going to do something to this one.
But it's in 2. That is 1.5.
Everybody say that?
Yes, sir.
Okay. So I've just cut my 1 in 2. Now, this part over here, let's look at the size of this part here and this size. Are the sizes?
Yes, sir.
Yes. What say you, Zaria? Are the sizes the same?
Yes, sir.
Yes. All right. So over here we have 2 parts, right? This whole thing is now divided into 2 parts, right?
Yes, sir.
And both 2 parts are equal, don't?
Yes, sir.
Okay. So here is, I'm going to put a slash, and we're going to call this slash the vinculum, right? Now, this slash, I'm going to put a 2 at the bottom here.
2/2.
Hold on. Here's my 2. Now, from what we know about fractions, this 2 represents which of the numbers? Numerator or denominator?
Both of them, sir.
Denominator.
Huh?
Both of them, sir.
Look at where the 2 is.
Denominator.
Denominator. Daria? The number in the bottom will be the denominator. All right, now I'm going to put a 1 at the top here.
Mm.
Now, there's my 1.
So
No.
that is a 2.
Now, what this 1 is telling me is the amount of, this 1 is telling me the amount of equal parts I have given to somebody, for example. Are you guys clear so far? This 2 down here tells us the amount of total equal parts. So again, the 1 says 1 equal part. All right. Let me use my, so it's equal. Oh, what is that? Who's drawing that? This is 1 equal part. Are you seeing that? And here I have 2 total equal parts. Everybody seeing that right now? Zaria, John?
Yes, sir.
Okay, so my 1 here is telling me the amount of equal parts that I've given away to somebody. And this 2, which is in my denominator, is telling us the amount of total equal parts that we have. All right? So this 1 over 2 means I have 1 equal part out of, and this slash here reads out of, this one here reads out of 2 total equal parts. Anybody have any questions so far?
Yes, sir.
Go ahead. Question?
Sure, so like if this part is shade, the part that you have to shade is part right here, and this part is equal, it's going to still be off, right, sir?
Which part?
The shaded part, because there are 2 equal parts. Total of 2 parts that are the totals, the same size, but there's 1 equal part. So
Right, so there's 1 of it that has something in it, as you said before. Okay?
yes.
So this part is the only equal part that has something in it. Or it's the only equal part that I gave to somebody. Okay? Or that I'm talking about right now. This part. This part is not in consideration. All right? Good so far?
Yes, sir.
Okay, let's look at this. Look at this one. Now, if I do this, what do I have here? Can I represent this as a fraction? What fraction is shaded right here?
1/4, sir.
1/4? What do you say, Dujan? Yes, Dujan?
1/3.
1/3? Now, I want everybody to tell me. So Zaria says 1/4. So if that's 1/4, Zaria, what does 1/4 mean? What does
Sir,
1? Go ahead.
that 1 part of the set is shaded.
That's all it means?
And there are 4 on that. There are 4 sections that are the total equal parts are 4.
But what there you already said total 4 total equal parts. Are these parts equal, Zaria?
No, sir.
No. So is this 1 that we shade? Is it 1 equal part out of 4 total equal parts of the whole?
No, sir.
No. So is this 1/4?
Unequal.
Huh?
No, sir.
No. Okay. What about this, Zaria? If I remove this. What about this? What fraction is this?
Yeah, that is 1/4.
That's 1/4.
Right here.
What do you say, Zaria?
Yeah, I agree with the John sir.
1/4. Okay, tell me, why is this 1/4?
Because there are 4 equal.
Sides are equal on both sides.
Say again?
Because there are 4 equal parts.
There are 4 total equal parts.
Yes, sir.
So remember, the denominator tells the amount of total equal parts of the whole. All right? Okay?
Yes. Yes.
So this was a whole, and I have divided my whole into 4 equal parts, total equal parts. That's what the denominator tells us. All right? The numerator tells us how many of my total equal parts are actually under consideration. Am I clear?
Yes, sir.
So this says 1 equal part out of 4 total equal parts. Read that for me again. Read this for me.
1 equal part out of 4 equal parts.
4 total equal parts. Again.
1 equal part out of 4 total equal parts.
One more time.
1 equal part out of 4 total equal parts.
One more time.
1 equal part out of 4 total equal parts.
Of the whole. All right? Dejan, your turn. Read this for me. Dejan. All right, while we wait, Dejan. So Zaria, if you have this, Zaria, what is this saying to you? Hold on.
Yes, sir.
I'm coming, Dejan. Dejan, read this for me right here. What is it saying to you?
1/4.
Yeah, what is it saying to you?
1 is numerator
Yes.
and 4 is the denominator.
And what does it mean? It means 1 equal part out of 4 total equal parts of the whole. All right?
Yes, sir.
All right, go repeat it for me. 1/4 means? Come on, let's go. 1/4 means?
So there are 4 parts and 1 is shaded out of 4.
I know, but I said it means. We need to know what it means. It means 1 equal part out of 4 total equal parts, okay?
Yes, sir.
So read this to me again.
1 equal part is taken out of 4 equal.
4 total equal parts.
4 total equal parts.
One more time.
Sir.
Come on, Dejan, you can do it. Yes, okay, Zaria. This one, no, Zaria. Read this one for me.
1 equal part out of 3 total equal parts.
Okay, of a whole. All right.
Yes.
So what it means to you, Zaria, is that whenever you see a fraction always means that you have some amount of equal parts out of some amount of total equal parts that you divided your whole into. You following, Zaria?
Yes, sir.
Okay. Now, Zaria, I'm going to erase some of these on the board right now. But in a few seconds, what I want you to do for me is read this to me one more time. From here.
Right now, sir?
Yes, right now.
Okay, a fraction has two main numbers. A numerator, which is the top number, and the denominator, which is the bottom number. The
Numerator.
numerator tells the amount of equal parts, and the denominator tells the amount of total equal parts of the whole.
As a whole. Are you seeing the picture now?
Yes.
Getting the picture clearer?
Yes.
Okay, so let me erase the board. And we say what fraction means equal parts out of total equal parts of a whole. All right? Now, let me clear the board and show you something. Now, before you said something about mixed fractions, I have a question for you, Zaria. This is what you're talking about, don't you?
Yes, sir.
Okay. Read this to me.
1 whole, and 1/3.
Okay. Is all of this a fraction, Zaria?
Yes, sir.
Is it all a fraction? Listen to yourself.
No.
Huh?
No, sir.
No. Is this part here, is the 1 a fraction?
No, sir.
It's a whole, isn't it?
No. It's an old number.
It's a whole number. So this whole number is not a fraction, right? The only part that's a fraction is the 1/3. Isn't that true? Isn't that true?
Yes, sir.
Okay, good. So it means that even though it is called a mixed fraction, Zaria, only the whole of it is not a fraction. What this fraction means is this, Zaria. It means you have one thing. You see that? And then the same size thing, Zaria and Dujan, the same size thing, what happened to it is that it is divided into 3. Okay?
Yes, sir.
You see that, Zaria?
Yes, sir.
So, in essence, and then out of this 3, only this part we're talking about. You see that?
Yes, sir.
Okay. So that means we have 1. So this is a whole. This is 1. And this part here is 1/3, right?
Yes,
good to go? Okay.
Yes.
So now, do you understand why a mixed fraction is not entirely a fraction?
Yes, sir.
Right. So all fractions have 2 numbers, Zaria, a numerator and a denominator. Are you clear, Dujan?
Yes, sir.
Okay. So there's... Go ahead, Zaria.
No, I was saying you keep on putting yourself on mute, sir.
Okay. All right, so let's go again. Now, I'm going to ask you to read these for me. Read this for me. All right, go ahead, Zaria. I want you to read all of them for me.
1/5,
Yeah.
2/3, and
Yeah,
3/4.
Read it and tell me what do they mean. All right, I want you to tell me what they mean. Okay, go ahead.
1/5. It means 1 equal part out of 5 total equal parts.
Of a whole, right?
Yes, sir.
Okay, this one.
And the second one is 2/3, which means 2 equal parts out of 3 total equal parts of an whole.
Next one.
The last one, the third one, which is the last one, means 3/4, which means three equal parts out of 4 total equal parts.
Of a whole. All right, now Zaria, I want you to represent the first one for me.
Sir, I can't find the bottom of my screen. Just saying Jermaine on screen.
Okay, tell me what you want me to draw. Should I draw? I'm going to put some things on the board and you tell me when to stop drawing for you, all right? So that's one. Should I put another one?
No, sir.
Is it 5 things you need or just one?
Just one, sir.
Just one. Why you only need one thing?
Because that is all it said. You need one to represent one. All said to represent the 5 things in. Because you will take it. Because remember I said 1 equal set out of 5 total equal set.
Of a whole, right?
Yes, sir.
So that means how many wholes must we be dividing?
5. 1.
One. So this is one whole, right?
Yes, sir.
Okay, good job, good job. So that's one whole. So what we're gonna do with this whole?
We're gonna split it up in 5.
In 5 what?
In 5 columns.
What must the columns be? Must they be equal or not equal?
Equal.
Equal. Okay. Something like this.
Yes, sir.
Something like that.
Yes, sir.
Okay, good. Now, how many of them has something?
1.
One. So I should shade 1, right? Okay, good job.
Yes, sir.
Good job. All right, now the next one. How many boxes do I need for the second one?
2, sir.
2. Okay. 2 boxes for this one?
Yes. Yes, sir.
Why do I need 2 boxes?
Because
No man, I said we're doing the second one. We're doing the second one now. This one.
this because there's 2 also.
It's 2 wholes, or is it 2 equal parts out of 3
Yes,
total
2
equal parts?
wholes, 2 equal parts. Yes, sir.
So how many wholes should we have?
2.
2. Why 2?
Because
Go ahead, think. Are you mixing up wholes with equal parts?
yes, sir.
Okay, so how many wholes must we have?
2.
All right, remember, what's a fraction? Tell me what's a fraction.
1.
A fraction is a number that has two numbers, a denominator and a numerator.
And what does it tell you when you see a fraction?
How much equal parts are there?
Out of what?
Out of what is supposed to be shared or shaded.
Out of the total equal parts.
Yes.
Of a whole. All right? So it means, Zaria, that you have one whole and you're dividing it into how many total equal parts?
3.
3. Okay. So it's just one whole, all right? It's always one whole that you're dividing to make fractions. All right? Cool?
Yes, sir.
Okay, so here I'm going to divide this whole into 3. Now, how many of these 3 total equal parts actually have something?
None, sir.
Based on the fraction we have here.
2, sir.
2. Okay, good. 2. Good. Right. So 2 must have something. So any 2. 1, 2. All right. You good to go, Zaria?
Yes, sir.
All right. So remember, the key here is that it's always a whole, one whole that is being divided to create a fraction. All right. And it can only be considered a fraction if every single part of the whole is equal in size. Okay,
Yes.
Zaria? What did I
Yes,
just say?
sir.
What did I just say?
That it's only 1 hour is 1 whole, sir. All. So everything and one all is always everything that is equal.
Everything to make a fraction, the whole must be divided into equal parts.
Equal parts.
Okay. And that's how we can consider some part of a whole to be a fraction. All right?
Yes, sir.
All right, good. Now, let's look at some more here. Clear the board? Zaria. So tell me, is a mixed fraction entirely a fraction?
Repeat again, sir.
Is a mixed fraction entirely a fraction?
No, sir.
No. Why not?
Because the whole number, a fraction only has 2 numbers.
Right. And a mixed fraction has three type of numbers. Well,
Yes.
it has a whole number.
It's
A mixed fraction.
And not fraction.
A mixed fraction has a mixed fraction is a fraction and a whole number. That's what it is.
I told you.
So a mixed fraction is a fraction and a whole number.
And
What is a fraction? A fraction has a numerator and two numbers. Two numbers. A numerator and a denominator. Good job. All right, here goes. Now here is a fraction. All right, tell me what these two fractions mean to you. Go ahead, Zaria. What does those two fractions mean?
One equal part out of 2 total equal parts.
Of a whole. Don't miss that part.
Of a whole, yes. And the second one is one equal part out of 3 total equal parts of a whole.
Okay, good. Now look at this, Zaria. What is this number? What's that number?
1 whole.
Okay, and this number over here is how many?
2 whole.
Okay, good. Now pay attention here, Zaria. If I'm to represent these things, 1 whole is that, right?
Yes, sir.
And this is 2 wholes mean how many?
2 things represented.
Question. Must the 2 things be the same size, shape?
No.
Think about it. If you say
Yes.
2 wholes, must they be the same size, shape?
Yes, sir.
And the type?
Yes, sir.
Yes. So if I'm talking about 2 wholes, they must be the same type of things, right?
Yes, sir.
And they must be the same shape things, don't?
Yes, sir.
And they must be the same size things, don't?
Yes, sir.
Okay, good. So, and if I'm talking about one whole over here, it must be one thing. It's just be one thing, right? One complete
Yes,
thing.
sir.
All right, good. Now, if I'm talking about a fraction here, how many wholes must I have represented here for this fraction 1/2?
How many wholes? One whole, sir.
One whole. Because we say a fraction is always a portion of a whole, right?
Yes, sir.
Okay. And this is how many wholes I need over here too?
One.
One. Okay.
One, sir.
One. Excellent. So my question to you, Zaria, is the number 1 down here says 1 whole. The number 2 over here says 2 wholes. Okay? All right, Zaria? So my question to you is the 1 whole and the 2 wholes, they're all the same size, shape, and type, don't?
Yes, sir.
Okay. Now, if I was to add my 1 whole and my 2 whole, how many holes would I get?
3, sir.
3 holes. Excellent. So we'll get 3 holes. So that would equal to 3 holes, Zaria?
Yes, sir.
Okay. All right. Now, my question to you is this.
Say next question because they give us the question to you and keep on having a next one. So they say
All right.
next question, sir.
Your question. Go ahead. You have a question?
If I have a question,
Yep.
to give you,
Yeah, any question?
okay, you have 3 O's
Mm-hmm.
and you had 5 other O's. So you add that. How much did you get? How much holes do you have in
8 holes. 8 holes. Zaria?
Yes, sir.
Okay. All right, so here we go. Let's look at this now. Now, if I have this Zaria, if I have this, is this a whole anymore?
No, sir.
What is it called now?
A fraction.
Which is a what?
When you have 2 numbers
Mm-hmm.
and which are the numerator and denominator.
Okay. Okay, and so this is an equal part of a whole, right?
Yes, sir.
Okay, good. Now, can we add these two things together?
No. Yes, sir. No, sir.
No? Okay. Talk to me. Why not?
Because you no longer know a whole number. Oh, yes, sir. You can add it. Yes, you can add it.
You can add them?
Yes, sir.
We can?
Yes, sir.
Are they the same size?
No, sir.
Shape?
Yes, sir.
They are the same size and shape?
No, sir.
Okay. So you said that this is a half, right?
Yes, sir.
So this is a half. And this is 2, right?
2. Yes.
Okay.
Sir.
So, question to you again, Zaria. Are these things the same size?
No, sir.
This over here and this over here, they're not the same size.
No, sir.
Are they the same type of things?
Yes, sir. Because no, sir. No, sir.
What's the difference between the type of thing?
Type depends between type of sticks.
Aren't they the same? Aren't they the same? Aren't they rectangles?
Yes, sir.
But okay.
But
Go ahead.
but it takes up.
I didn't hear that.
But it takes up but the half takes up all the circle, so it's not a rectangle again because it's going to be a square because obviously you take the half of it takes up half of it square, so it's going to be a rectangle, and the two is over here is going to be a square, a rectangle, and the half over here is going to be a square.
Okay, so you're saying that this is a square now.
Yes, sir.
Okay, so they're not the same type of things. Okay, very good. All right, so before a while ago, we had the one hole and the two holes, and we could have added them, right?
Yes, sir.
Because they were the same type, shape, and size, right?
Yes, sir.
Write that down in your book for me. Miss Stewart went through this with it already, don't?
No, sir.
Addition. She didn't go through addition with you?
Addition with fractions.
Not fractions, but she went through the concept of addition with you, didn't she?
Yes, sir.
Okay, and what did she say? What kind of things can you add?
They can add numbers. Fractions. Whole numbers, cars, everything you can add.
So remember, Zaria, remember this for today and forever. We can only add things that we can only add things that are the same size, shape, and type. Okay, Zaria? Make sure you write that down.
Finished, sir.
Excellent. So a while ago, again, we could have added the one hole and the two holes because they were, all three of them were the same size, type, and shape, right?
Yes, sir.
But now we don't, we have a situation where we have a half and we have two holes, right? And so can we add them?
Yes, sir.
Okay, what do you add them when you get?
2.5.
Okay, but how do we add these procedurally? We do get 2.5, but as
Sir,
if you look at them, can you add these two things naturally as they stand?
no,
Just the way they are? No. But how else could we represent two holes?
2 holes, 2 half.
Question, Zaria. Is this, if I do this, do I still have two holes?
That was what I'm gonna say. I said 2 half, and I said.
Okay, good. Do we still have two holes here?
Yes, sir.
What's the only thing we just did?
I just put the cross, just make it in 2 parts.
Okay, so in other words, I divided the two holes into 2 equal parts, right?
Yes.
Okay, good. So now, Zaria, and did I change anything at all, really?
Yes, sir.
No, I still have two holes, right?
Yes, sir.
I just divided them into smaller parts, right?
Yes, sir.
Okay, so now, is everything looking like the same size?
Yes, sir.
What about type?
Type. Still, yes, sir. It's still the same shape.
Oh, and the shape. Everything matched on?
Yes, sir.
Okay, great. So can we now add these things together?
Yes, sir.
Yes. So when we add them together, what do we get? Count them. 1,
6 holes.
how many holes?
3 holes.
Is it?
Yes, sir.
Is it 3 holes? No, man, Zaria. Remember, this is the only part over here that has something, you know.
No. Oh, sorry, sir. 2.5.
It's 2.5, right?
Yes, sir.
Because we have a half plus a half plus a half plus a half plus a half. Done.
2.5.
2.5, right?
Yes, sir.
Are you seeing everything there? So half, and half give us 2.5. Okay, Zaria?
Yes, sir.
Good. So the concept here is the only things we can add are things that are the same size, shape, and type. Clear? Crystal clear?
Crystal cryptic clear.
Okay. Tell me what you understand so far from those.
That when you mark out one of set of like when you represent one fraction, meaning that you mark out like this one, you mark out with this, and you have two like 3 wholes, you can add it with a half and get 3.5 whole.
Is it 3.5 wholes, Aria? Look at it.
No, I was just giving other examples, sir.
Oh, I'm sorry. Go ahead.
Yeah, and you have three holes, and you add it with another half, which is when you have one hole, and you put it in two, you divide it in two, and it represents as one. So you represent as one, and you have another half of it, and you just add it to the 3, you get 3.5.
3.5. Okay. But can you add the holes as a whole, or must you make them look the same size?
So you have to make the same size.
Excellent. And by making them the same size, we don't change anything really, do we?
No, sir.
No. Okay, let's go up to the top now. Ready? All right, this is what? Read this fraction here for me again.
Okay. 1 equal parts out of 2 total equal parts of a whole.
Okay, which means this, right?
Yes, sir.
Okay, next one. Next door.
1 equal parts out of 3 total equal parts of a whole.
Which means this, right?
Yes, sir.
Something like that? Something like this, Aria?
Yes, sir.
Okay, good. Now let's look at this, Aria. If I put a plus sign between here, right?
Yes, sir.
And say to add them, can we add these as they are?
Yeah, no, sir.
Why not?
Yes, sir, I can add them.
Okay, think before you talk, right? What kind of things can we add?
Fractions.
Read down here. So we can add things that are what?
The same, that are the same size, shape, and type.
Okay, good. So now a half and a third, are they the same size?
No, sir.
Are they the same shape?
Yes, no, sir.
Are they the same type?
No, sir.
No. Okay. So then if none of those things match, then we have to do something about it, right?
Yes, sir.
What did we do down here?
We just divide it into 2 parts.
To try and get everybody to be the same size, right?
Yes, sir.
Okay, let's try with this. How do you think I can get these things to be the same size?
We can either erase one of those. No.
Without changing the value. Without changing the value. Remember, we're not changing the value. So let's go.
Add in another circle.
Add another what?
Hole.
Add one more hole to it.
Yes, sir.
And what will that do? What if we do this?
We can't just. That was what I was supposed to say.
What if we do that? And look over here. What if we do this? You know the diagrams aren't drawn to scale, right? They're not so accurate, right?
Yes, sir.
Because both of these holes are to be the same size. Remember that?
Yes, sir.
So if we do that, we get them to come down to be the same size, don't?
Yes, sir.
Okay. So my half, I just divided my half by a half, don't?
Yes, sir.
What happened a while ago? Okay, so I just divided my half into half. Sorry, I just split my half into, my bad, there's Aria. Hold on, let me do this. Give me a second, all right? So if I divide my half, there's Aria,
Yes, sir.
into 1, 3. You see that? And my third, I'm divided into 2, right? 2 halves. That's
Yes,
true.
sir.
All right, now, do I get everything to be the same size?
Yes, sir.
That's it. Look at it, Zaria. Remember, I not draw properly, you know, so let's make an estimate. Are they about the same size? Look at it. They look similar, don't they?
Yes, sir.
Okay. Sure?
Yes, sir.
Excellent. Okay, so what did I do to the half? I remember this was the half, right?
Yeah. So you divide it into more parts, sir.
How many parts? What did I divide? What kind of parts did I divide it into?
You divide it into 4 more parts, sir.
Is it 4? Look at my half. So the half here?
3, 3, 3, 3. Yes, sir. No, sir. Yes, sir. No. Yes, sir.
I divided into 3, right?
Yes, sir.
Okay, so my half is divided into 3. Good? Now,
Yes.
what about my third? What did I divide it into?
2, sir.
Divided by 2. Okay, so I divided my third by 2, and I divided my half by 3. See that, Zaria?
Yes, sir.
And that way, I got both of them to be the same, both fractions to be the same size, shape, and type. See that?
Yes, sir.
Did I change the, isn't this the same thing as 1/3? Here, look at it. Take a look at that. This is 1/3, right? But my 1/3 is now how many? How many parts will make up my 1/3 here?
2 parts, sir.
2 parts. Out of how many? Total equal.
Oh, that's 6, sir.
That's 6. Okay. And my half. How many parts make up my half?
3 out of 6, sir.
3 out of 6. Excellent. 3 out of 6. So now the question is, Zaria, can we now add these two fractions together?
Yes, sir, because they have the same denominator, sir.
Yeah, we same denominator now. Okay, good. But what else is the same about them?
They are this. No, wait a minute. They have the same. Sorry about nothing else.
Okay, so we said they have the same size.
They have the same
and
answer.
type. Okay, so you realize now, Zaria, that once the denominators are the same, it means that they are the same size, shape, and type. Okay, Zaria?
Yes, sir.
That is why we make the denominators the same in a fraction, because we want to get them to be the same size, shape, and type. Okay?
Type.
When we add these
Yes.
fractions, how many do we get?
6, 3, 5, 6, sir.
5, 6. Okay. 5, 6. Okay.
Yes, sir. Yes,
We
sir.
get 5, 6. Any questions, Zaria?
No, sir.
Crystal clear?
Yes, sir.
Okay. So what could you say, what mathematically, what did we do to the 1/2 to get 3?
Plus, working. We just 1/2. We just convert it.
Yeah. By doing what? What mathematical operation did we do to get 36?
By adding
Adding how many?
2.
Adding 2. And what did we do to the bottom here to get 6?
We multiply
By what?
2.
2 times 2 give us 6?
No, I think.
All right, we want a consistent operation. Is either we're going to add something to get this, or we can multiply this by something to get this. Which one?
We're going to cross and multiply.
Multiply. So what do we multiply the 1 by to get 3?
1, 3.
1 times 3, right?
Yes, sir.
And what did we multiply the 2 by to get 6?
2, 3.
Excellent. What about the 1/3? What did we multiply it by to get 2?
3. The top one we can multiply by 2, and the bottom is going to multiply by 3.
And the bottom one we multiply by what?
You can multiply by 2 or 3.
Okay, so this was 2, right?
Yes,
I'll multiply this by 2, right? So 2 and 2. And that's how we get 2, 6, right?
Yes, sir.
Okay. So you realize over here, the bottom number is 3, right? The denominator is 3. And over here, the denominator is 2, right?
Yes, sir.
Excellent. So I want you to write this down, make a note of it.
First, we're gonna do the algebra and the fraction.
Tonight?
Yes, sir. You said you were going to.
I probably won't be able to do it.
But sir,
Yeah?
I want to sleep.
Say again?
I want to sleep.
So the next time.